periodic table, metals which have in last shell 3 electrons are less than 3 electrons. The elements which have in its outermost shell 3 are less than 3 electrons are called as metals. And the elements in its outermost shell which have more than 5 or more than 5 electrons, that are called as non-metals. Okay, S black elements are called as metal, P black elements are called as non-metal. Okay, S black elements are called as metal, and D black elements will be there no third group to 12th group, that are called as transition elements. And lanthanides and actinides will be there no, that belongs to third B group, so that also that are called as inner transition elements. Okay, next, all elements in the S black are metals. So in the periodic table, we can classify the elements into S black, P black, D black, and F black. So how can we classify that? Now we will discuss. For example, hydrogen is there in first A group. So hydrogen atomic number 1. Its electronic configuration 1s1. So here differentiating electron entering into S non. That's why it is called as S black. Lithium is there. So lithium atomic number 3. Electronic configuration 1s2. 1s2, 2s1. Last 2s1 is coming or not? That's why it is S black. That's why it is S black element. Sodium is there. Its atomic number 11. Its electronic configuration 1s2, 2s2, 2p6, 3s1. Last s1 is coming or not? So that's why it is also a S black element. Potassium is there. It is atomic number 19. So it's differentiating electron entering into S. Okay, potassium atomic number 19. Electronic configuration 1s2, 2s2, 2p6, 3 2s2, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, last electron entering into S orbital. So that's why it is called as S black element. Okay, so beryllium, once you observe its electronic configuration, beryllium atomic number 4, electronic configuration 1s2, 2s2. Okay, so S2 is coming. So S2 is coming and the last electron entering into S orbital. So that's why it is also called as S black element. Magnesium atomic number 12, electronic configuration 1s2, 2s2, 2p6, 3s2. 3s2 means S2 is coming. So last electron entering into S orbital. So that's why it is called as S black element. So remaining calcium, strontium, barium, radon also like that only. That last electron entering into S orbital. So we can call that as a S black element. Okay. Next, once we observe the boron, boron atomic number is 5. Okay, electronic configuration 1s2, 2s2, 2p1, 1s2, 2s2, 2p1. Last electron entering into p orbital, that's why it is called as p black elements. Carbon, carbon atomic number 6. Its electronic configuration 1s2, 2s2, 2p2. Last electron entering into p black, no, that's why it is called as p black element. Nitrogen atomic number 7. Electronic configuration 1s2, 2s2, 2p3. This last electron entering into p orbital, that's why it is called as p black element. Oxygen atomic number 8. Electron configuration 1s2, 2s2, 2p4. Last electron enter into p orbital, that's why it is called as p black element. Okay. Next, F, fluorine, atomic number 9. Electronic configuration 1s2, 2s2, 2p4. Last electron entering into p orbital, that's why it is called as p black elements. Fluorine atomic number 9. Its electronic configuration 1s2, 2s2, 2p5. Last electron into p orbital, that's why p black element. Okay. So like this, if the last electron entering into which orbital, that's why we can call them as a last electron entering into which orbital, then we can call that element as a particular black element. If the last electron entering into S black, if the last electron entering into S orbital, then we can call that as a S black element. If the last electron entering into p orbital, then we can call that as a p black element. Okay, so this already we discussed in the previous class. Now what is that means? For example, scandium is there. Its atomic number 21. Its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So the last electron entering into 3d orbital, no, that's why we can call this scandium as a d black element. Okay, so here we discussed in the yesterday topic d black elements. Okay, means third group to 12th group, that are called as d black elements. Why? Because the differentiating electron entering into d black, that's why that are called as d black elements. Next, cerium 58. Okay, its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6, 6s2, 4f2. Here the last electron entering into f black. No, that's why we can call that as a f black element. Means if the differentiating electron entering into s orbital, we can call that as a s black element. If the differentiating electron entering into p black, then we can call them as a p black elements. If the differentiating electron entering into d orbital, then we can call that as a d black elements. If the differentiating electron entering into f orbital, then we can call that as a f black elements. Like this we can classify the elements into s, p, d, f blacks. Okay, so all elements in s black are metals. So all elements in the s black are metals, whereas in p black except 18th group, okay, whereas in p black except 18th group they are metals, non-metals and metalloids. Okay, in periodic table you will notice a staircase like demarcation. So the elements to the left of this demarcation are metals and the right are non-metals. Okay, the elements on staircase are very near to it, like boron, silicon, arsenic, germanium, etc. are called as metalloids. So once you observe the periodic table, in that periodic table we can notice a staircase like demarcation. Means near the boron, aluminum, silicon, germanium, okay, and antimony, polonium, there one dark line structure like steps like structure is there. Once you observe that near boron, aluminum, boron means 13th group near, okay, 13th, third A group there after the boron downside, and one steps like structure, okay, near the boron, aluminum, silicon, germanium, arsenic, antimony, near the polonium, steps like structure, staircase like structure will be there or not there? There. Okay, once you observe that he showed with dark line, okay, steps like structure is there. Okay, so we will notice a staircase like demarcation, means steps like structure is there. The elements to the left of this demarcation, okay, so once you see the periodic table, the elements left side of this demarcation are called as the elements left to this demarcation are called as metal. Okay, so these steps like structure left side which are there, that are called as metal. Okay, next and right are non-metal. Okay, the steps like structure right side, okay, the staircase right side means steps like structure right side, which elements are there, that are called as non-metals. Okay, next the elements on close to staircase, okay, like boron, silicon, arsenic, germanium, boron, silicon, arsenic, germanium. Okay, these are called as metalloid. So this is staircase left side which are there, that elements are called as metal, staircase right side which are there, that are called as non-metal, and near to staircase which elements are there, like boron, silicon, germanium and arsenic. Okay, these are called as metalloids. Okay, now we will discuss about one more topic, periodic properties of the elements in the modern table. The modern periodic table is organized on the basis of the electronic configuration of the atom of elements. Okay, so the modern periodic table is constructed on the basis of the electronic configuration of the elements. Yes or no? Yes. Okay, so already we discussed in the previous topic also. So last differentiating electron and okay, first A group elements, that all electron configuration is coming S1, S1, S1 like that. Second A group elements, it's a kind of electronic configuration coming from S2, S2, S2. Okay, so like that it is coming or not? Boron is there, it's atomic number 5. Its electronic configuration 1s2, 2s2, 2p1. 2p1 means in last shell 3 electrons said that there are not there, means 1s2, 2s2, 2p1. Means 2 is second shell. In that how many electrons are there? 2s2, 2p1 means 3 electrons are there. Third group like that. Okay, carbon Carbon is there. Atomic number 6. Electron configuration 1s2, 2s2, 2p2. In this last shell, which one? 2s2, 2p2. Okay. Second shell is last shell. No. In that what? How many electrons there? 2s2, 2p2. 2s2, 2p2 means 2s2, 2 electrons, 2p2, 2 electrons. Total 4 electrons means fourth A group. Nitrogen. Atomic number 7. Electronic configuration 1s2, 2s2, 2p3. Last shell is second shell. In the second shell 2s2, 2p3. 2s2, 2 electrons, 2p3, 3 electrons. 2 plus 3, 5 electrons. Fifth A group. Like that. Okay. Oxygen. Atomic number 8. Electron configuration 1s2, 2s2, 2p4. Okay. 2s2, 2p4 is last shell. 2s2, 2 electron, 2p4, 4 electron. Total 6 electrons. Yes or no? So like that it will come. So the modern periodic table is organized on the basis of the electronic configuration of elements. Next, the physical and chemical properties of elements are related to their electronic configuration, particularly the outer shell configuration. So the physical and chemical properties of elements are related to their electronic configurations, particularly the outer shell configurations. The atoms of the elements in a group possess similar electronic configuration. Okay, so the elements which are in the same group that have similar electronic configuration means like S1 hydrogen, 1s1 lithium, 1s2 2s1, okay, sodium 1s2 2s2, 2p6 3s1, like that similar configuration will come. Once you observe the each and every group and write its configuration, so same configuration will come. Okay, so therefore we expect all the elements in a group should be have similar chemical properties and should be a regular gradation in the physical properties from top to bottom. So in one group, which elements are there, that all the elements are similar outermost configuration. So that's why that have similar chemical properties, that have the similar chemical property. Okay. Similarly, across the table from left to right, in any period, elements get an increasing in the atomic number 1 unit between the two successive elements. Okay. Therefore, the electronic configuration of valency shell of any two elements in a given period is not same. Okay. So in period, if we observe from left to right, this atomic number is increasing. Okay, atomic number is increasing or not? Once you observe the lithium, beryllium, lithium atomic number 3, beryllium atomic number 4, boron atomic number 5, carbon atomic number 6, like this atomic number is increasing or not? Increasing. Therefore, electronic configuration of a valency shell of any two elements in a given period is not same. So it's in a period left to right, atomic number is increasing. So the electronic configuration of this valency shell of any two elements is not same. Due to this reason, elements along the period possess different chemical properties with regular gradation in their physical properties from left to right. So in period left to right, atomic number is increasing and the no two elements does not have same electronic configuration. So the elements does not have similar outermost configuration. That's why due to this reason, the elements in the period possess different physical and chemical properties. Okay. To understand this, we will take some properties of elements and discuss how they are vary in groups in periods. Okay. So I said no, in group which elements are there, that all elements having outermost configuration same. But in period, when we are going from left to right, atomic number is increasing and its electronic configuration also not same. Okay, that's why that have different physical and chemical properties. But in the group, all the elements have similar outermost configuration. Okay, so that's why its chemical properties, physical properties are similar. So that one we will understand by observing some properties. Okay, so to understand this, we will take some properties of elements and discuss how they are vary in groups and periods. Okay. The modern periodic table is organized on the basis of electronic configuration of the atom of elements. Okay, and the physical and chemical properties of elements are related to their electronic configuration, particularly the outer shell configuration. So this model periodic table is there, no, that is consisted by depending on the electronic configuration. Okay, so the elements which have similar outermost configuration, that are will come in one group. Okay, so that's why the physical and chemical properties of elements are the related to electronic configuration, particularly the outer shell configuration. So the model periodic table is organized on the basis of the electronic configuration of the atom of the elements, and physical and chemical properties of elements here are related to their electronic configuration, particularly outer shell configuration. Next, the atom of the elements in the group possess similar electronic configuration. Therefore, we will expect all the elements in a group should have similar chemical properties, and there should be a regular gradation in their physical properties from top to bottom. So means here it is nothing but, so in group, if you take one group, in that group all the elements having a similar outermost electronic configuration. So this outermost configuration is same, no? Then what happened? The physical and chemical properties also similar. That physical and chemical properties also similar from top to bottom. Similarly, across the table, from left to right, at any period of elements get increases the atomic number by 1 unit between two successive elements. Therefore, the electronic configuration of valency shell of any two elements in a given period is not same. Due to this reason, elements along a period possess different chemical properties with regular gradation in their physical properties from left to right. So, to understand this, we will take some properties of elements and discuss how they vary in groups and periods. But if we compare in periods, then what happens in periods? When we are going from left to right, atomic number is increasing, and when we compare the electronic configuration of the elements, note so that electronic configuration of the elements also different. Okay, the electronic configuration of valency shell of any two elements in a given period is not same. Okay, once you compare the electronic configuration of the elements in any period, that is not same. So in period, if we compare the okay, take two any elements from any period. For example, second period is there. In that, take two elements like lithium and beryllium. Observe its configuration. That outermost configuration is not same. Okay, lithium atomic number 3, this configuration 1:2s1. Beryllium atomic number 4, its configuration 1:2s2. Like that, outermost configuration is not same. Difference is there. Okay, due to this reason, along the period, that possess different chemical properties. Okay, so to understand this, we will take some properties of elements and discuss how they vary in groups and in periods. So here in periods, outermost configuration is different. That's why that have different physical chemical properties. No two elements does not have same physical and chemical properties. In groups, all the elements have similar chemical properties. Yes or no? Yes. Okay, so the in group which elements are there? That all the elements have similar outermost configuration, and that's why its physical and chemical properties are same. Okay, in group which elements are there? That all elements have similar outermost configuration. That's why it have same physical and chemical properties. But in period, elements does not have similar outermost configuration. Difference will be there. So that's why these have different physical and chemical properties. So to understand this, we will take some properties of elements and how that is different in groups and periods we will take. Okay, so in groups, same physical properties, the elements which are there that have same physical chemical properties we said. In periods, that are outermost configuration is different, that's why that have different physical chemical properties we said. So to know this, we will take some properties of elements and how that will be changed in the groups and periods. Now we will discuss. Okay, what are the properties? Valency, atomic radius, and ionization energy. Next, electron affinity and electron electronegativity, and metallic and non-metallic properties. How these properties all change in period and groups, now we will discuss. Okay, in groups which element is there that have similar chemical properties, we discuss. And in period, which elements are there that have different physical chemical properties, we discuss. So to know this, we'll take the properties of some elements and we will observe. So what are the properties? Okay, to understand this, we will take some properties of elements and how that is changing in the groups and periods. Now we will discuss. What are the properties? Valency, atomic radius, next ionization energy, electron affinity, electronegativity, and metallic and non-metallic properties. So how these properties are different in periods and groups, we will discuss in next class step by step. Okay.